So welcome to this channel. Today I want to discuss this topic called continuity. Anytime they tell you to define continuity, okay, they will give you this, a function. They will also give you this. And finally, they will give you this. They will give you these three things, okay? So when they give you these three things, because they will give it to you, and they say define continuity, the first thing you tell them is that limit must exist. And the question is, what do we mean by limit must exist? I mean, this is the first condition for continuity. Limit must exist. What I mean by that is this. When you are doing limits, it is compulsory for you to do what we call the left hand limit and the right hand limit, okay? You do the left hand limit and you do the right hand limit. Now, you're going to write limit. You will pick this. You write it under x approaches a. Then you evaluate the function as x gets close to a. You get your answer. That is your limit. But remember, this is a left hand limit. That means I'm going to write a minus. Now, the meaning of minus is that I am trying to get close to a, but from the left, okay? So when you see a minus, it means I'm getting close to a, but from the left. So I've done left hand limit. So do the same thing for right. So for the right, you're going to have limit x approaches a plus. The a plus means that I'm approaching a again, but from the right, okay? Then evaluate your function when your s gets close to a from the right. Now, when you do this, okay, and the answers are the same, you know, I said something before, that when you do these limits, you won't get a definite answer. I mean, you won't get this. You won't get whole number. No, you won't get this. No. You are not going to get a whole number, but you will get an answer that is very close to each other. So when I say limits of this, I'm saying that you may not even get a whole number, but these two answers should be equal. So when you establish this, the limit exists. So when the left hand limit is equal to the right hand limit, limit exists. That is the first condition for continuity. Now the second condition for continuity is this. Now this one is without limit. Let me say it again. It is what? Without limit. That you don't need to use limit at all. So please don't use this and don't even use this. So you don't need this. Don't write limits and don't write this. Do you understand? So what we now do instead, just pick the function f of x, okay? Pick the function f of x. Now instead of you to say x approaches a, no, don't do that. Just take your x. Take your x, okay? Replace your x with what? Your a, directly. Don't even do limits, don't do x approaches a, just replace your x with a directly. Now if this thing is equal to L, is equal to your limit, okay, then the second condition is what? Satisfied. Now when these two conditions are satisfied, then you've defined what? Continuity. So in continuity, we have two conditions. Condition number one, limit must exist, which is why we're here. Left hand limit is equal to right hand limit. Then condition two, without limits, just do direct substitution, okay? Don't write limits, don't write this, just replace your x with a, and the answer will be a real number, something like this, a real number, okay? So once you get this answer, then you've defined continuity. So when they say define continuity, these things must hold. But how will you now combine all of this? So you will say that in defining continuity for a function, now after giving you these three things, you're going to write them together. You're going to say limit x approaches a from the left of the function is equal to limit x approaches a from the right of the same function is equal to. Now without the limits, if I replace my x, this my x, if I replace it directly with my a, now if all these answers are very close to each other, all the answers are very close, they're all equal to each other, then you've defined continuity. And that's all. That's all. So if you have any question, you can let me know, okay?